Hi everyone, it's Mr. Rops here. We're going to talk now about the angle of elevation and depression. And so imagine I have a scenario here, and if you look here, there's a little man here, and there's an airplane and there's a car. From this man, you have to recognize that there is a horizontal line that goes right straight across here. Right? There's a horizontal. Right? There's also a horizontal that is at the car, and there's also a horizontal line that is from the airplane's perspective. Okay, so I have three different things. So from the man, if I go look up to the airport or to the airplane, it creates an angle here. If I from the man looking up, so the horizontal up, this is called the angle of elevation. Okay, and so similarly, if I go to the car, and if I go from the horizontal up, from a horizontal upwards is again, it is the angle of elevation. Okay. However, if I'm standing at the man and I go from the horizontal down, this angle here is called the angle of depression. So the horizontal downwards. So from the airplane horizontal downwards, this is the angle of depression. Okay, and imagine if there was, like, the car could look into the earth, this here would be the angle of depression, always from the horizontal down. Okay, so angle of elevation is always from a horizontal up. So a horizontal, and I look up to that angle is the elevation. For the angle of depression, the angle of depression is from a horizontal down. It goes from a horizontal and it looks down, and that is the depression. Make sure you get the ideas from a horizontal. Let's try an example. Okay, so a man looks out to sea from a cliff top. So I got a cliff here, and there's a sea of some kind, so I know it's a right angle. And here is the man at the cliff top, we'll call it M. And the cliff top is 12 meters. I'll get all that from here. He sees a boat that is 150 meters from the cliff top. Well, here's the cliff top. So here's a boat out at sea, right? From the cliff top to the boat is 150 meters. That's what this says here. What is the angle of depression? Well, in order to get that angle, we have to find the angle of depression. Well, here's the man. I know here's the horizontal. Always from a horizontal, and sometimes you have to put it in. This angle here is the angle of depression. So I have a right angle here. I also have a right triangle here, where this is 12 meters to find theta. So if I want to find theta now, I know from theta, this is the opposite, and this is the hypotenuse. So opposite and hypotenuse, so the opposite and hypotenuse is sine. So the sine of theta is equal to 12 over the hypotenuse of 150. And so theta will be the inverse of sine, 12 over 150, which if I go to my calculator, I go second sine, 12 divided by 150. And my angle of depression is 4.59 degrees. This is the angle of depression, okay, from the horizontal down. And you often have to place your own horizontal onto your diagram to find it. Okay, let's try one more problem here. Okay, so Gunther is at the Berlin-Tegel airport and watching the planes take off. He observes a plane that is at an angle of elevation of 20 degrees. So here's Gunther. Here's my angle of elevation is 20 degrees. The plane is at a height of 350 meters as shown in the diagram. Calculate the horizontal distance of GH. So I want to find this distance here. We'll call it X. Well, from my 20 degrees, this is the opposite and this is adjacent. Opposite over adjacent, and adjacent deals with tangent. So the tangent of 20 is equal to the opposite over the adjacent. If I do some quick algebra here, I know X will be 350 over the tangent of 20. If I plug this in my calculator, I get 350 divided by tangent of 20. And so I get this is equal to 961.617. But I want to give it the answer to the nearest meter. So I know that's 962 meters because I round this up. So Gunter is 962 meters from point H here. Okay, that's A part. Let's go to B part now. The plane took off from T, not double T, just T, which is 250 meters from where Gunter is standing, as shown in the following diagram. Use your answer from A part, which here was GH, to calculate ATH, this angle here, which is the angle of elevation. So I know I rounded a 962 for A, but I'm going to keep all the decimal places so that my final answer is accurate to 3 significant figures. So we are looking for this angle here, which I'll call theta. I know if this is 250, the whole distance was 961.17, so I know TH will be 961 minus the 250. So I'm just going to go for my calculator. I'm going to keep this value here, and I'm going to subtract the 250. And even though I'm only going to write 711.6, I'm going to use all these decimals in my calculation. And so if I want to find theta, I know this is opposite, and this is adjacent, which is tangent. So tangent theta is equal to 350 over 711.6. Now, even though I'm writing that, I'm going to use all of those decimal places. And so I'm going to do tangent inverse of these values will be 350 over 711.6. And so I go to my calculator, I go second tangent, 350 is exact, divided by, and now I'm just going to go up to this value and take it, hit enter, and it will put all the decimal places in there, close my parenthesis, and so now I have 26.2 degrees, and this is to 3 significant figures. That is angle T that I'm looking for. If you don't keep all your decimals appropriately, sometimes this rounds to the incorrect accuracy error, to the wrong spot. So be careful with your decimals, and there's your problem for the day.